force is something that changes state, right? Just like force, inquisitiveness has driven you here. So today we are going to talk about Coriolis Force, Foucault pendulum. So let's talk about what is Coriolis force. In the last lecture we found that when a particle or an object is just resting on earth, it will feel a centrifugal force, right, which is a pseudo force. But when it is traveling with some velocity, then it will experience a Coriolis force as well. So we had derived the formula and all. Let me write them down today. For centrifugal force, the expression was m omega square r minus, it is a pseudo force, it will act in a negative direction. So F Coriolis was minus 2 m minus 2 m omega cross VR, right? This is the formula. Here you can see that the centrifugal force doesn't depend upon whether the particle or the object is traveling or not, but the Coriolis force is dependent upon the velocity, means this force will act on a moving object. So we know about pendulum. Actually from a pendulum named Foucault pendulum, it was found that the Coriolis force acts on a particle on earth which is moving, right? So let us suppose this is our earth, this is north pole, this is south pole. We will make some reference frame and coordinate system to understand these things. This is the axis of earth along which the earth is rotating from west to east with a constant angular velocity which is omega. Let us suppose this is equator and this is a position of a observer doing some experiment or just present here. So here the position vector for this point will be r, and we know parallel shifting of vector, so this omega vector we can shift this to this place, right? Let us call this vertical axis as x. This x-axis will be known as vertical axis and this horizontal axis as z. So let us suppose this is north direction, and obviously when we are making orthogonal coordinates we will need a perpendicular vector which will be perpendicular to both x and z, which will be y, which will be an inward axis, but representing in a 2 dimension we will show this something like this, and this is y. As this is north, y direction will show east direction. You can use this just like, no, we know that this is north, this is east, this is west, this is south, right? Just shift this, take this and put it just like this. You can feel that this will be north, a outward axis will be west, inward axis will be east, and opposite to this north axis means minus z will represent our south, right? So here the angular velocity omega is here. It will have two components. Let us see that we know that we will have a latitude at a point on earth let us assume that the latitude here is phi. We will drop a parallel axis with the equator. This is perpendicular to equator, so this both of this angle will be same. This will be phi, and as this is phi, this angle will be 90 minus phi, right? And as this is 90 minus phi, this is both x and z are perpendicular to each other, so this angle will be phi, right? Omega makes an angle phi with the z axis. Let me erase all this and make this particular thing clear so that you can visualize everything clear. So from this picture you can see that omega vector will have two components, one along the vertical axis or x axis, that will be omega sin phi, and but horizontal component along x axis, that will be omega cos phi. So we know that the formula of Coriolis force is minus 2m omega vector cross Vr vector, right? So actually the vertical component of the Coriolis force will result into our acceleration due to gravity, that is g, but the force experienced along horizontal direction will make the difference. So we are going to talk about the horizontal deflection or the horizontal force due to means horizontal component of this force. So here you can see that there is two component of omega vector. The force will have direction perpendicular to both omega vector and velocity vector. So for a horizontal component of the force, we need a vertical component of omega, because to be perpendicular to the force, the omega vector should lie on vertical direction, because force will lie in horizontal direction. So here the vertical component of the omega is omega sin phi. It means that the vertical component of force, means the Coriolis force, will be due to omega sin phi. Clear, right? The horizontal component of force rises due to omega sin phi, the vertical component of the force. So let us suppose a person is traveling with velocity v along z axis, and obviously we have the vertical component omega sin phi along x axis. So now we are going to search for the direction. So here we can see that omega cross Vr means this will be the direction, but as there is a negative sign because it is a pseudo force, the direction will be inverse. Means if you are standing here, you will feel that the deflection is towards right side, right? And this will be the this will have an opposite case in case of southern hemisphere. Means obviously the direction will change in northern hemisphere and southern hemisphere as we put our direction convention in an opposite manner in southern hemisphere. You can see it yourself by making some vectors and doing something like this. You can feel this thing. So now we are going to talk about Foucault pendulum. Before that, I would like to tell that you know about storm and the winds have some spiral manner, right? Why this happens? Because there is a Coriolis force being acted on the wind and makes it rotate like rotate the wind in a circular manner. Because suppose the wind is going this way, the Coriolis force is being applied along this direction, so it will just go in this manner, rotate, right? Then storm will build, and obviously you know the consequences. So how to see that actually Coriolis force being worked? We can't actually experience this force when you travel a short distance, but this force is observable when something or someone travels a long distance. So these effects are generally experienced on flights and all, but this thing was actually observed by a French scientist, Foucault. So uh, after his name, this Foucault pendulum was named. What is this Foucault pendulum actually? So this is 70 meter long and has a bob of 28 kg. You can imagine how long the pendulum might be. This is not a normal pendulum in our labs. So this due to this long length, 2 pi under root L by G, and this L is a really very large quantity. So time period of this pendulum was 17 seconds. So when actually the pendulum was oscillated, the scientists noticed that the pendulum is not actually rotating vertically. After some time, it is rotating clockwise. Actually, I don't remember what he observed at the time, because I will go to that topic after some time. So let me first explain you why this happened. Because a pseudo force being acted on it. I'll show you a video in which the pendulum, sorry, I don't have any pendulum to show you, so I just tied my pen drive with a string and just oscillated it, and then I just displaced it from a distance with some acceleration. I don't, obviously I had no idea about the amount of acceleration, but I just displaced it with a high acceleration, so it started rotating. Why this happened? I wanted to show that the thing was, the pen drive was actually accelerated, just like our earth, and after this was accelerated, a pseudo force acted on it, and because of that pseudo force it started rotating. I'll show you that video. So here I am oscillating my pen drive, and after some time I will just suddenly accelerate it, then I will see that the pen drive is rotating, means it has some angular acceleration now. So this was the same for the Foucault pendulum, but the force was Coriolis force. So now it was observed that a pseudo force being acted on it, right? So what will be the direction of rotation? The direction of rotation will be clockwise in northern hemisphere, and in southern hemisphere it will be anti-clockwise. You can do it with the same vectors and coordinate systems. I would like to show you for northern hemisphere. So for northern hemisphere, the force will act towards right. Let us suppose in the case we are studying about before, it was along east direction. So let us suppose the force is acting along east direction. The pendulum is oscillating along the north-south direction, means along the horizontal direction. So force being perpendicular to the plane containing the pendulum, it will just push it, and then it will rotate clockwise, right? And for southern hemisphere, obviously the direction conventions are opposite, and it will experience a anti-clockwise rotation. So direction of storm are different in hemispheres due to this Coriolis force, right? So we are going to do 1 to 2 problems about this, and in next class we will try to solve more, but after the theory is complete I will try to solve the questions. For now only 1 to 2 questions. So here is a beautiful question on Foucault pendulum. I will dictate it, you write it down, try to solve it. If not possible, then watch this, I will solve this. So prove that the plane of oscillation of Foucault pendulum rotates 150 degrees sin phi per hour, where phi is latitude of the place. So actually let me tell you, Foucault pendulum spelling is Poucuc. LT Foucault's pendulum. Actually this is a French name, so here the letters are silent and not like that of ours where all the letters are pronounced. So here only you have to pronounce Foucault pendulum. So we have to prove that the plane of oscillation of Foucault pendulum rotates 15 degrees sin phi per hour. So first let us suppose the Foucault pendulum is rotating with a latitude phi, right? We know that the Foucault pendulum is rotating, means it has a angular velocity, right? In this case, as omega is this, and Foucault pendulum will obviously rotate in a horizontal direction, we know that. So the component of the angular velocity of the Foucault pendulum will be along vertical direction, means it will have the omega cos phi value, sin phi, omega sin phi value. And here we know the value of omega, right? Omega is what? The angular velocity of Earth. What is the angular velocity of Earth? Omega is the angle covered 22 pi by the time taken, 24 hours. Omega is this. So 2 pi by omega will be equals to 24 hours. So for this Foucault pendulum, the value of omega will be 2 pi by time period. What is the time period here? We have to calculate. Here actually the value of angular velocity of the Foucault pendulum is not omega, as we can see, it is omega sin phi. So instead of omega we will write omega sin phi. I hope we are clear. If any doubt arises about this, you can comment and I will try to make you understand, and in case you need some extra video about the topic, I will try to make them also. So here the time period will be equals to 2 pi by omega sin phi, right? So here 2 pi by omega is 24 hours. So time period of a Foucault pendulum is 24 hours by sin phi. This is the thing I have forgot before. Now in this question I have covered this, you note it down. So what was the question? Actually I forgot after driving this. The question was what is the angular velocity, right? How much angle does this cover? Does this Foucault pendulum cover in 1 hour? So here we will need omega equals to 2 pi by theta. Sorry, time period equals to 2 pi by theta. Let us suppose it covers angle theta with 1 hour. In 1 hour it covers an angle theta. So time period will be 2 pi by theta. Now we have to use this equation because t equals to t. So we will find 24 hour equals to 24 hour by sin phi equals to 2 pi by theta. We know that 2 pi equals to 360 degree, and then we will just flip the equation, cross multiply and get the value of theta. So let me erase all this and make this clear. Other question is asking the angle in degrees, so we have to convert pi radian into degree. So 2 pi equals to 360 degree by theta. Now just cross multiply it and then divide 24 hours. This is really very easy. You can do this and get the result. Theta equals to 360 into sine phi by 24 hours. This will be equals to 15, means theta equals to 15 degree sine phi. This means it will cover this much of angle in 1 hour. So this is for today. In the next lecture we are going to talk about free fall, and after that we will do some numericals. So after that the chapter will be covered, and thank you.